Unit 2, Understanding the MapReduce. Okay, so out of this, we have completed the Hadoop MapReduce and its fundamentals, and we have completed writing the MapReduce example also using the Java programming language, and then we are about to deal with these last 2 points today, that is learning different ways to write MapReduce in R, and then integrating the R and Hadoop, that is RHIPE architecture and R-Hadoop. Okay, so these points we are going to cover today. So these things we have already done. Now, what are the different ways to write the MapReduce in R? So, as you know that R is getting consistent popularity because it has the inbuilt things which are required for the statistical analysis. Okay, so there are many packages and libraries that are being developed uh, in R, and that is why this R is increasing the popularity. Okay, and it is not only efficiently able to deal with the statistics, but it is the map reduce also. So there are packages and algorithms or programs that can run with the log of R, and then the computational power of Hadoop has been combined over here. Okay, so we require some middleware to deal with this R and Hadoop. So these are the middleware, that is R-Hadoop, RHIPE, and Hadoop streaming. So these are the middleware that will help us to develop these things, this scenario. Okay, so what is the meaning of Hadoop middleware? The middleware means now it is clearly that this will be one program. Okay, so this is your R program and this is your Hadoop program, and there should be some middleware which sits between these two, because R is efficiently able to do the statistical analysis, and Hadoop is going to do efficiently the mm, map reduction work with the help of huge amount of data. So these are the middleware, that is R Hadoop. Okay, so all these are the middleware, RHIP and Hadoop streaming. Okay, all these are the middleware that are developed using this within the R. Okay, so the first one is R Hadoop. So R Hadoop is a open source software framework. It is used for performing the data analytics on the Hadoop platform with the help of functions or methods which are available in the R language. Okay, so there are three different packages. So you must be knowing. I think I have already taught you this in last lecture, that RD, RHDFS, RMR, and RHbase. These are the three packages which are readily available in the R to deal with the MapReduce functionality. Okay, so RHDFS, it is the R package for providing all the Hadoop HDFS access to R, and all the distributed files can be managed with the R functions which are defined in RHDFS. Okay, then second package is RMR. Okay, so this package is providing the interface, that is MapReduce interface to R. So with the help of this package, the mapper and the reducer can easily be developed. Okay, so mapping and reduction की क्या functionality है, क्या facility है, we have seen at length, and using this RMR we can easily develop these things with the help of R programming language. Okay, and then there is RH base. So this is the R package for handling the data at the H base, that is Hadoop based distributed database through the R programming language. So these are the three important packages: RHDFS, RMR, and RH base. Okay, then next one is your RHIP. So R and Hadoop integrated programming environment, R HIPE. Okay, R is a programming language, and Hadoop integrated programming environment. It is again the open source and freely available project or source code is available. RHIP is widely used for D and R, that is divide and recombine analysis. Okay, so that means huge amount of data is getting divided, and then you are recombining that. Okay, so D and R analysis is used to divide huge data, process it in a parallel manner using the distributed network to produce the intermediate output, and finally it recombines the intermediate output into the set. So these are nothing but your map and reduce functionality. Okay, so it is designed, RHIP is designed to carry out the D and R analysis on the big data, and it is developed by these PhD students. Okay, so this is that. Then the third way is Hadoop streaming. Okay, so it is the utility that comes with the Hadoop distribution, and it allows you to create and run the MapReduce jobs with any executable or script as a mapper and or reducer. So within the R programming language, you can write your mapper or you can write your reducer, or both mapper or reducer. So these are the some of the supported programming language, that is R, Python, Bash, Ruby on Rails, and Perls, and so on. Okay, so also there are package named Hadoop streaming. Okay, so this is name of the package, Hadoop streaming, and this package will deal with the data analysis on the Hadoop cluster with the help of R script. Okay, so this is also available. Additionally, it also allows running MapReduce tasks without Hadoop also. Okay, so that thing is also available. Now the last point is understanding the architecture of this RHIPE. So it is library developed for integration of R and Hadoop. So these are the components: R client, then job tracker, task tracker, and HDFS. So we know at length what is the difference between job tracker and task tracker. The job tracker is a master node and task tracker is a slave node, and ultimately the task tracker is going to do the mapping and reduction job. Okay, and then they are going to use the HDFS as their file system to read and write the data. Okay, and once this job tracker does its work, it will submit the job resource to HDFS. Okay, so these are the components. So first component is R client. As you can see, this is your first component, R client. So it is an R application that calls the job tracker. Okay, it calls the job tracker. Okay, so this job tracker is your master node. This is your master node and this is your slave. Okay, so then to execute the job with an indication that the map reduce job resources such as mapper, reducer, input format, output format, input file, output file, and there are other several parameters that can handle by this MapReduce jobs with the help of R client. Then next is your job tracker. As you can see in this diagram, the job tracker. So it is a master node. Job tracker is master node, and it is used for initializing and monitoring the MapReduce job given to the task tracker. ठीक है, job tracker क्या करेगा? Job tracker will monitor task tracker. So it will be monitoring what kind of tasks these task trackers are doing or not. Okay, then next component is your task tracker. So as you can see, so this is your first component. Which one? R client. So this is first, this is second, this is your third component, and this is the fourth component. So there are four components in RHIPE. Okay, so the third component is your task tracker. Task tracker is nothing but it is a slave node. Okay, so task tracker is a slave node in the Hadoop cluster, and it actually executes the mapping and reduction job as per the orders given by the जॉब ट्रैकर. ओके, सो जॉब ट्रैकर ने जो ऑर्डर दिए है वो सारे टास्क ट्रैकर एग्जीक्यूट करेगा. इट विल रिट्राइव द इनपुट डेटा एंड रन द आर स्पेसिफिक मैपर एंड रिड्यूसर ओवर इट. ओके, सो ये डेटा कहाँ से लेगा? डेटा विल बी टेकन फ्रॉम द HDFS. ओके, so it is going to get the data, it will run the map and reduce job, and then write it back to the HDFS. So read and write operation will be done by the slave node. Okay, and finally the output will be returned to the HDFS directory. So the next is your HDFS. So it is the file system distributed over the Hadoop cluster with several data nodes, and it provides the data services for various data operations. Okay, then next is your R-Hadoop. Okay, so this is another way to deal with this. So again there are three packages: RHDFS, RMR, and RHbase. Just now we have seen, and each of them offers the different Hadoop feature. Okay, so what are they? The first one is RHDFS. So it is the interface providing HDFS usability from the R console, and it also you can write the output in on the HDFS, and it is very easy to access them by calling the RHDFS methods. Okay, so basically this package calls the HDFS API, okay, application program interface backend, to operate data sources stored on the HDFS. The next is your RMR. So this is providing interface for MapReduce facility inside the R environment, and so that the programmer needs to just divide their application logic into map and reduce phases. So as we have seen that there will be the map phase, there will be the reduce phase. In the same way here the things are going on. Okay, and after that RMR calls the Hadoop streaming with several job parameters as input directory, output directory, mapper, reducer, and so on over the Hadoop cluster. And that is how this RMR works. Okay, then last is your RH base. So it is the interface for operating the Hadoop edge-based data source stored in the distributed network. Okay, and this RH base package is designed with several methods for initialization and read write and table manipulation operations. Okay, so this is the architecture of this R-Hadoop. So as we know that there are HDFS, RMR, and RH base. So this is the diagram that shows the R-Hadoop ecosystem. Okay, so these are the packages. So R interface for calling Hadoop MapReduce API, that is RHDFS, RMR, and RH base. Okay, so these are the connectors for the various ecosystem environment system parameters. Okay, so this is the end of your unit 2. Okay,